Welcome, everybody, to today's webinar on BECCS, Bioenergy with Carbon Capture and Storage. My name is David Morrow. I'm the Director of Research here at the Institute for Carbon Removal Law and Policy at American University. I'll be moderating today's webinar. And I am very pleased to welcome our three outstanding panelists today. We have Dan Sanchez from the Department of Environmental Science, Policy, and Management at University of California, Berkeley. Sam Savitz, an analyst with the Energy Futures Initiative, EFI, and Mehron Tesfaye at the Bipartisan Policy Center here in DC. Also a Berkeley PhD, I believe, so Berkeley's well represented here today. Before I turn things over to our panelists, a few quick logistical remarks. The first half of our webinar or so will consist of presentations from our three panelists, followed by Q&A with the audience. Other than myself and the panelists, everyone will remain muted throughout the webinar, so please use Zoom's Q&A function to submit your questions, and I will pass those on to the panelists. This webinar is being recorded. If you have to step out early, the entire webinar will be posted to the Institute for Carbon Removal Law and Policy's website at carbonremoval.info. That's carbon removal, all one word, .info. And so without further ado, Dan, why don't you tell us about BECCS?
Sounds great, and thanks everyone for the opportunity to speak today. I'm going to walk briefly through some slides, providing an introduction to bioenergy with carbon capture and storage, or BECCS, or BECCS as it is perhaps affectionately known. I'm a professor of cooperative extension at UC Berkeley, and I've spent much of the past decade studying these technologies and similar technologies that use biomass to remove carbon dioxide from the atmosphere. So when we talk about how we remove carbon from the atmosphere, there are really kind of two approaches. One of those uses biology. Plants, when they grow, they use photosynthesis, they fix CO2 out of the air and they store it in their plant biomass. And we can use things like plants or grasses or trees or other kind of biological processes in order to store carbon in places like the land or in the ocean. On the other side of the equation, we have engineered carbon removal technologies, and these are approaches that use chemistry primarily to remove CO2 from the air. They can include things like storing CO2 underground in deep geologic formations, storing CO2 in long-lived products, or storing them in things like concrete and other kinds of building materials. Just to give you an idea, again, these biological approaches, they can span things like restoration and management of terrestrial land or aquatic ecosystems, carbon farming, as it's affectionately known, but the idea that we can change our agricultural practices to store more carbon in soils. On the other side, in engineered, we have direct air capture technologies. These use chemistry to concentrate CO2 from its concentration in the atmosphere, which is 0.04%, up to nearly pure CO2, where it's captured and typically stored underground in a geologic formation. We can do similar things by mining reactive minerals and exposing them to the air and using chemistry to suck up that CO2. Bioenergy with carbon capture and storage sits at this really interesting kind of interface between the biological and the engineered approaches, and the more time that I've spent thinking about it, it really embodies both the best and the worst of these biological approaches. And I think that's why BECCS can look like such a promising technology, but also a scary and harmful technology if not implemented correctly and with proper sustainability limits. BECCS is an approach that uses biomass that grows, and so uses photosynthesis as kind of the first step of removing the CO2 from the atmosphere, but then uses lots of chemistry and engineering to make different products to capture the CO2 and to store it in some kind of long-lived product or formation. So let's focus on bioenergy with carbon capture and storage. Just walking you from the left to right of this figure, biomass, when it grows, as I said before, it fixes CO2 from the atmosphere. That biomass is then harvested and transported to an energy conversion process coupled with carbon capture and sequestration. And it really makes two different products. One is an energy product that can be electricity or fuels or hydrogen or take your pick. It also creates CO2 that's available to be compressed and sequestered or fixed in another product. It gets a lot more complicated from that once you start breaking down what's in those boxes and what those things actually represent. There are a lot of different potential sources of biomass available for BECCS. Some of those can be classified as wastes or residues, which can help us feel more comfortable about their sustainability impacts. But some of them also include dedicated energy crops or primary forests or other things that we grow and manage and harvest already. The biomass is then brought to a production facility where they can use either what are known as thermochemical methods using heat and catalysis to make products, or biochemical methods using enzymes and yeasts and bacteria to turn the biomass into the final products. And the final products can be heat, electricity, liquid fuels like gasoline or ethanol, drop-in fuels, or gaseous fuels like hydrogen or renewable natural gas, really anything you can think of. And the trick here is that all of these processes during their conversion process give off a stream of pure biogenic CO2. That was carbon that was recently in the atmosphere before it was stored in biomass. And capturing and storing that allows these processes to have net negative emissions or be carbon removing. I think we understand and know that carbon removal technologies play a tremendously large role in stringent climate change mitigation scenarios. About 5 or so years ago, maybe a little bit further back, BECCS was modeled and represented in these portfolios at scales by mid-century and end of century as large as 10 billion tons per year or larger of carbon removal using bioenergy with carbon capture and sequestration. That is a tremendously large number. It is likely not compatible with planetary boundaries and sustainability, but it's kind of how BECCS was thrust into the limelight of climate change mitigation. But we need to be frank that really there is not billions of tons of this technology deployed right now. We're talking about millions of tons. And really to this date, we're talking about one project in the central Illinois in the United States, where they're capturing CO2 from a very large dry or wet mill ethanol facility, capturing it and storing it on site. And this is a biorefinery operated by Archer-Daniels Midland, one of the largest kind of agribusinesses in the Midwest of the United States. So again, this is a really simple system. We're just basically capturing pure CO2, running it through pumps and compressors, and storing it about 5,000 feet underground in what's known as the Mount Simon sandstone. There are 3 really good seals on top of that where we're storing that CO2, so we hope it will stay there. And all evidence to date is that it has. But this is what's going on in Decatur. I think there are a lot of other places where we can talk about deploying BECCS, and that's where most of my research focuses. Ethanol is really a kind of low-hanging opportunity. People are talking about building, multi-billion-dollar, multi-state pipelines to move CO2 from biorefineries to where we can put it underground, kind of crisscrossing the Midwest of the United States. Producing biogas is another really exciting opportunity. We won't be able to get into that today. Another really parallel technology is biochar production, which stores carbon in a long-lived carbonaceous compound rather than in deep geologic formations or products. But in many ways, biochar and BECCS are kind of close cousins, if you will. There are other places where we can capture CO2 from biomass. That includes pulp and paper facilities. You can actually even run direct air capture machines using biomass and bioenergy. Well, there's some reasons why. There's some really strong engineering synergies between the two systems. But I think suffice it to say that, we need to spend a lot more time talking about realistic scenarios and near-term implementation of this technology. That's what I hope the rest of our panelists can really focus on today and that we can bring out during our discussion. I'll just say a couple of hypotheses. I think we're gonna take advantage of kind of some of these low and no cost CO2 capture methods that naturally arise when returning biomass into products. I think that's going to be a place where we start to capture CO2 and put it underground. It's going to be a really near-term market. I think these facilities are in many cases going to be a lot smaller than we expected, and modularity is, both a good thing and a bad thing. You can have a lot of systems, but these are small systems, and so the trade-offs between those costs can be hard. And then, really understanding what realistic BECS is. It means that we need to understand regional conditions, regional market demands, and sectoral policies. And we need to think about BECS outside of the electricity sector, which is where it was kind of shoehorned in the first place. I'll end by saying that the state of California is making a lot of progress on this. We have policies in place to pay for carbon negative things. We have grant money available for biomass with carbon capture and storage that we're going to try to be deploying this year. I really suspect it's going to be kind of a first market in the United States and in the world for these technologies. Want to make sure we have time for everyone else, so I'll stop here and really look forward to the question and answer and the discussion. Thank you.
Thanks, Dan. That was really helpful. I want to turn next to Sam, one of the authors of EFI's recent report on BECCS, to tell us what they found in their survey of the BECCS landscape.
Sure. So thank you, David. Thank you to the Institute for inviting me to present on our findings. For EFI is a Washington, D.C. based think tank. We were founded by former Energy Secretary Ernest Moniz back in 2017. We focus on climate solutions based on innovation and technologies, policies, and business models. So we've been researching carbon dioxide removal since about 2018. Our first report, which was called Clearing the Air, proposed an $11 billion, roughly, whole of government research and development program for carbon removal across a wide range of technologies. And what we found in the course of writing that report was that there's really a disproportionate focus in Washington, both from a research perspective and a policy perspective, on only certain technologies within the family of carbon removal, and specifically on direct air capture and on natural solutions, like Dan talked about with forestation, soil carbon, things like that. So after clearing the air, we went on to write a series of reports that we called Frontiers of CDR on some of these lesser explored areas like ocean methods or mineralization methods. And then we wanted to turn to BECCS, in part because of this big focus within integrated assessment modeling that Dan talked about. So our first stage of this project, which we call Sowing the Seeds of a Negative Carbon Future, is we did a literature review that we called Surveying the BECCS Landscape. And we released this report in January. We identified a series of key findings that I'll walk through today. The second phase of the project involves diving deeper on specific subjects that we wanted to delve more into, including by working with some other folks on this panel. And you can see the topics that we're diving into there. We held a public workshop to kick off phase 2 last week on Wednesday that featured the current Secretary of Agriculture, Tom Vilsack. And that should be available online later this week if anyone wants to go and check it out. And our second phase will culminate in another report that will focus really on policy dimensions for BECCS. So our first couple of findings here, the first one really repeats a lot of what Dan was talking about with the scale of BECCS, that the Intergovernmental Panel on Climate Change projected that you might need up to 8 gigatons, 8 billion tons of BECCS by 2050. But that this potential for BECCS really stands in as a substitute for other sorts of CDR, and that the likely scale might not be quite that large, but that the potential is still vast, something between 3 and 30% of total global emissions could be potentially removed with BECCS. And in the US in particular, there's a large potential to possibly up to 1 or 2 gigatons. But that deployment is low right now, that there are 16 projects globally, but only that one in Illinois that's really large scale. The rest are all at pilot and demonstration scales. Despite that, the US is sort of especially suited to BECCS in a couple of different ways. We have this existing bioenergy industry. You can see in the map on the right, this shows both the location of current and planned BECCS projects, as well as current bioenergy facilities, specifically those that would be eligible for the 45Q tax credit for carbon sequestration. And so in addition to having this huge existing industry that you could add carbon capture to or work with on BECCS projects, that there's a high feedstock potential for additional bioenergy, as well as a large geologic storage resource for CO2. So we really take an expansive view of BECCS in this report. This breaks down similarly to what Dan showed, the various components of a BECCS process. But we found that a lot of the literature is focused on a narrow subset of these technologies, specifically on combustion of wood and wood wastes or on corn ethanol. But that there's, and specifically those with post-combustion capture and then geologic storage or enhanced oil recovery. So there's a whole world for each of these components of new types of feedstocks to look into, like engineered crops, new energy conversion technologies to look into, like production of hydrogen, for example, that could be really useful for decarbonization. And then new capture pathways too. So for example, we include the biochar process if it's producing an energy co-product as a type of BECCS as well. And this doesn't even capture the whole world of other sorts of things like bioproducts that could be produced through similar processes. But a lot of these technologies, they're at different stages of readiness. The corn ethanol and the wood combustion can be deployed right now, whereas some of these other technologies require more research and more demonstration before they're really commercializable. So one of the big issues we heard going into this project was BECCS isn't actually net negative, that because of the land use change required for feedstock growing, both direct and indirect land use change, that the emissions caused by that, or the emissions from other parts of the process, offset any removals that it has. And what we found is that, in fact, BECCS can certainly be net negative under the right circumstances, but that it's dependent. It's dependent on the specific project and the specific supply chain that goes into that project. It also depends on your accounting system and where you draw your system boundary, both in time and in space. But we found in particular that there's a lot of issues with greenhouse gas accounting, and a greater consensus is really needed in order to move BECCS forward. That each of these steps in the BECCS process that you can see on this slide have different questions around accounting. Some of them are more easy to solve than others, but that they need to be addressed before you can really have a full-scale BECCS system or BECCS deployment. So one thing we found also is, despite this extensive resource base in the United States, that you would still need a lot more infrastructure to actually deploy BECCS at the scale of hundreds of millions of tons or billions of tons. And that's both supply chains for biomass and infrastructure for energy conversion, and particularly for CO2 storage. The CO2 storage infrastructure is a big problem with getting deployment done today. But that coordination, a specific advantage of BECCS is that coordination with other sorts of technologies is really easy. There's specific synergies that BECCS can have. So some of these things might be shared CO2 infrastructure with other things like natural gas power plants, industrial facilities, or direct air capture. There could also be advantages of deploying BECCS in concert with natural solutions like forestation or forest management that prevents wildfires, helps prevent wildfires. And then in particular, BECCS is also useful for decarbonizing existing energy systems. It can provide carbon negative firm power. It can provide fuels that can help with existing decarbonization, that mitigation benefit in addition to the removal benefit. And we found that there's opportunities for regional hubs. For example, shared CO2 infrastructure, shared fuels production infrastructure, if you're doing something like hydrogen or renewable natural gas. This next set of findings on community impacts, I'm sure we'll hear a lot about in the next presentation, so I don't want to step on any toes, but the basics of what we found is that there's a key problem that applies to BECCS, but that's universal for all kinds of clean energy infrastructure, which is we don't want to perpetuate the inequalities that were created by former energy infrastructures or other sorts of infrastructures. Don't want to perpetuate that environmental racism or the burden of pollution. And so because several components of the BECS system have local, local pollutions, local emittance, that's something you have to worry about. We found at the same time, BECS has opportunities for communities. So you can see here that the traditional forestry industries like wood products and pulp and paper have lost a lot of jobs, roughly 500,000 over the last 20 years. And BECS can help put some of those, revitalize some of those communities, transition some workers to new jobs, and additionally transition workers in things like fossil fuel industries and communities that are dependent on those industries. And in general, BECS provides a really unique opportunity for rural economic development and job growth. Finally, this is something that we're delving deeper into in the second phase of our report, but the policy landscape for BECS. So the big problems for the policy landscape are that bioenergy and CCS have policies related to them, but not BECS together. The phrase BECS, bioenergy with CCS, didn't appear at all in federal statute until 2020. And even then, it's just one research program at DOE. But that these programs also are spread throughout the government. However, because there are all these programs that exist for things like bioenergy and CCS, there's a strong foundation to build on for BECS policy. So that could be things, for example, the renewable fuel standard that's administered by the EPA, which mandates certain amounts of biofuel in gasoline and diesel, the research and innovation at DOE, in particular, this new carbon removal research program, things like USDA, like the Biomass Crop Assistance Program, that pays farmers to produce biomass for energy, as well as USDA's role as one of the largest forest owners in the West through the Forest Service. And then, of course, tax credits, things like the renewable power credit, renewable fuel credits, and the 45Q credit that I mentioned earlier. None of these things are particularly adapted to BECS's net negative capabilities, so there needs to be new policy that really values that, but there is a foundation to build on. So with that, just want to say thank you again. And to check out our report as well as our webinar from our workshop from last week. And with that, I will hand it back. Thank you.
All right, thanks, Sam. As a reminder to all of our participants, if you do have questions about anything that any of our panelists have said, you can use the Q&A feature on Zoom to submit questions. You can do that at any time. And after our presentations, I will feed those questions to the panelists. Some of those issues that Sam raised about sustainability are especially important to us here at the Institute for Carbon Removal Law and Policy, which is why I'm very excited to introduce our next speaker, who is an expert on just those topics. So I will turn it over now to Meron Tesfaye from Bipartisan Policy Center.
Oh, are you all able to see my screen? Good. Okay. Hi, everybody. Thanks for having me, and thank you for the Institute for the opportunity to present a little bit of our thinking and our approach to BECS. As you have noticed from the last two speakers, there's a lot of complex dynamics that are embedded in this approach that encompasses various technologies. And for most of my time last year, I spent a lot of time thinking about what meaningful deployment of this technology would look like. And just to kind of maybe say a little bit more on what's already said. Of course, carbon removal solutions are a broad range, as Dan mentioned, and biomass-based solutions kind of lie at this really interesting but also challenging intersection of what we consider to be land-based as well as tech-based solutions. So this is largely stems from the origin of the fact that BECS or solutions that are biomass dependent use photosynthesis and biochemical systems to absorb CO2 from the atmosphere. And then that is converted into other useful products, as well as geologically stored underground using technology solutions. So this puts them at an interesting intersection, but as we've heard from the last two speakers, they are also really kind of struggling in terms of the deployment. And part of the reason is because they continue to kind of, BECCS continues to lie at the intersection of many interests, many stakeholders, and many value systems. And I'll try to highlight that, and I'll try to kind of point to how we're approaching that kind of intersectional approach. So as Dan mentioned, BECCS also kind of has dual benefits because of its ability to draw down CO2 and its ability to put CO2 underground. It has this carbon removal value, but it can also be used to produce these additional electricity, heat, or fuel, or other clean tech products. So it also has an energy value, and that puts it at a very interesting techno-economic as well as climate space, where as a carbon removal solution, it is cheaper and much more deployable than some engineered approaches like direct air capture, which is pretty expensive. But as an energy production method, it is more expensive than renewables, but also offers some climate benefits compared to fossil fuels. So the value system that we have right now kind of puts it at a very complex landscape. BECCS is also a multi-sectoral industry because it involves the full supply chain of not just where the biomass is sourced from, but includes harvesting and transportation and converting that into different end uses, as well as geologic storage. It involves multiple industries, of course, agriculture and forestry being kind of key drivers of the feedstock, and transportation, which includes both land and maritime, because we do have biomass shipping to UK and other places in Europe. Geologic storage industry is also quite important when thinking about BECCS. And then, of course, because of its end uses for energy, for fuel, for other heavy industry, and of course, because it has the potential to remove CO2, there's also emission credits that can be traded or because of this range of industries that it touches, it is also a multi-stakeholder space. And of course, we see that it has different impacts on those who own land and those who don't. It also interacts with natural ecosystems because the production of biomass could involve different types of additives like fertilizers and other things that affect other natural existing ecosystems. It also impacts workers that produce and process biomass. So agricultural and forestry workers are also impacted by BECCS deployment. And of course, proximal communities, but because it is a multi-supply chain system, communities that are near biomass sourcing, harvesting, transporting, and actual conversion and geologic storage sites could look different. So it affects different communities differently. Of course, as Sam mentioned, there's also local air quality concerns, which brings in a different set of stakeholders, as well as the global climate benefits that can be reaped from deploying such a technology. Last but not least, of course, investors and developers are also involved, and we need capital to flow in to deploy such a new and nascent technology. BECCS, of course, also lies in a myriad of social and political intersections. I'm sure I will not touch on all of them, but just to kind of call them out, there's a significant sort of urban and rural divide when thinking about BECCS deployment. A lot of the biomass resources are located in rural communities, and therefore their processing, their harvesting has to be located in rural communities, but some of the benefits can span to urban populations. So there's a divide as well as a differentiated stakeholder there. And as Sam mentioned, it does present significant rural development economic opportunities because of the job losses that we've seen for a lot of rural communities. BECCS also has, especially as a carbon removal solution, there's a balance that needs to be weighed, the risk and benefit balance that needs to be weighed, and that shows up differently. So it could be, there's some diffused local and direct benefits, but globally, obviously there could be significant climate benefits as well. So balancing all those kind of competing factors and investments and costs, and especially in terms of thinking about who pays that cost is going to be really essential. Of course, last but definitely not least is there's been various government and private actors historically that have caused harm, and environmental justice issues are also pretty central to thinking about BECCS and biomass resources. And so dealing with those and confronting those both historically as well as in our current approach to deploy this technology is going to be essential. So when we're thinking about this kind of approach of like, what does it mean to meaningfully deploy a technology such as BECCS, I kind of think about these four set of questions. And the question is, for whom are we trying to deploy that? For what, at what scale, and how? And I think some of the panelists have touched on some of the aspects of this, but we try to kind of approach that in an intersectional way, because the solutions don't just lie in one space. So the solutions are going to involve both the environment, balancing both the environmental, the social economical, as well as the technical aspects of BECCS. And we kind of see it as these intersections lying in the sphere, in the political sphere. And therefore, we see that policy has a really meaningful role to play in deploying, in meaningfully deploying BECCS. So to that effect, I had a really great opportunity last year to kind of think about this kind of multidimensional approach to a multidimensional technology. And we were able to develop a framework, or what I will call a scorecard, that has four aspects. And so the first one is sustainability. This is involves the production and the processing of the biomass, and that it's be sustainably sourced as well as produced. Of course, this cannot come at the cost of existing ecosystems or loss of any natural ecosystems. The second dimension that we really want to prioritize, because biomass as well as BECCS can have different set of values, we felt like prioritizing net negative emission through robust carbon accounting, through near-term deployment, and really prioritizing approaches that ensure net carbon removal to be pretty important. The third aspect is because the technology doesn't exist in a vacuum. The community well-being aspect of this technology is going to be really essential to meaningfully deploying it. Local community impacts have to be considered. The social and economic benefits that this brings has to be part of our thinking from the get-go. The last aspect really kind of tries to touch on who the players are in this space and how has it been done historically. So historically, there's been a lot of kind of really maybe missed opportunities for communication, harm associated with local deployment, some discriminatory practices. So there's really a need to rebuild that public trust, especially when it comes to biomass. And so we also proposed a few community engagement approaches to kind of round out the scorecard. So this kind of multi-dimensional framework can really also be applied, can be applied to both evaluate projects as well as develop policies. So just to give you a flavor of just a few policies that I think can touch upon these multiple dimensions. One that's been brought up a couple of times is this life cycle accounting, a standardized way of accounting for the full life cycle of biomass. We think that this has net sustainability benefits, net negative emission benefits, as well as community benefits, and builds trust in partnerships, because there's been a lot of kind of loss of trust when it comes to that. We have also, the Bipartisan Policy Center has recently also came out with a couple of reports that recommend targeted technical assistance for disadvantaged landowners and producers. This has really meaningful impacts for, especially for minoritized landowners, Black and Brown landowners, to really build community well-being while simultaneously reaping climate benefits. We also think that supporting near-term win-win opportunities by prioritizing waste biomass is another winner, and touches on these multiple aspects of BECCS. Just to name a little bit more, we also need to really develop long-term sustainable feedstock supply chains. This is critical for supporting rural communities, but it's also critical to ensuring sustainability of resources, and providing technical assistance to communicate not just the risks and benefits of BECCS, but all carbon removal solutions can really build that trust piece that I kept mentioning. And then last, but definitely not least, we certainly have more, but some supporting emerging markets and innovative products can also be a really near-term win that has net negative emission benefits while also building community economic well-being. So I will just stop there and express my gratitude to Bipartisan Policy Center. Some of the recommendation I draw are from our team, and most of this work I also developed at Carbon 180 through various conversations with practitioners, advocates, and technical experts. And so this is kind of our working and evolving understanding, and I welcome more questions. And me, I also have my contact here, and if you would like to read more about what I talked about here, I've also added the links. Thank you very much.
Great, thank you, Maro. All right, audience members, please do keep those questions coming in through the Q&A feature. The first question I'm going to put to our panelists comes from actually a couple of questions in the Q&A. There's some questions about carbon accounting at the Archer Daniels Midland BECCS facility in Illinois, which both Dan and Sam mentioned. Part of the question is whether there is a publicly available life cycle carbon accounting for that facility that's been published, and if so, where can we find it? And relatedly, I'll just quote directly from the question here, I think, because it also points to some of the trust issues that Myron mentioned. Quote, as of the most recent publicly available data from 2020, the facility was only capturing about 500,000 tons a year. And you'll remember that Dan had said it claims to be 1 million tons. Quote, is there any evidence or data which indicates that it's anywhere close to meeting the goal of 1 megaton per year? So it's a two-part question from two people. Is there a report about the carbon accounting for that facility? If so, where can we find it? And is there evidence or data that it will actually reach the 1 megaton per year claim?
Great. Well, I can try to get started on that. Yeah, we should be really clear here that BECCS is not always net negative, and particularly in the case of corn ethanol, that's going to be an issue that comes up again and again. You can reduce the life cycle carbon impact of kind of conventional corn ethanol by about 30 to 40% by capturing the fermentation CO2 emissions and putting them underground. But the life cycle emissions of growing corn, harvesting corn, transporting it to a facility, running a corn ethanol production facility, and getting it into a car exceed those the CO2, the biogenic CO2 that is captured and sequestered. And so it is a low carbon fuel. It's not a zero carbon fuel, and it's not a net negative fuel. And I think that often gets conflated here. If we use lignocellulosic biomass, particularly waste and residues, where we're more confident it's a very low carbon feedstock, BECCS is a net negative technology, and I think that really that often does get conflated. Regarding Maggie's question, this actually wasn't something that I was aware of. I would say that 500,000 tons a year feels close to meeting the goal of 1 million tons per year to me. I think it's great they're capturing CO2 and they've managed to deploy this technology, and that they're measurably and verifiably putting CO2 underground and complying with EPA regulations to do so. I don't know about their progress to meet the 1 million tons per year goal. That was based off of engineering estimates. Quite frankly, the time I really focused on this project was a few years ago when it was scaling up from the Illinois Base Indicator project to the Illinois Industrial CCS project. And there was extra money coming in from the US Department of Energy then, and a 1 million ton of CO2 per year goal. In terms of where that data is available, I haven't looked closely at like IRS filings or any of the information about 45Q compliance. One place to look, but I don't know if other folks have thoughts.
Yeah, I think I'll jump in on that. So on the question of finding data first, I don't know about a life cycle analysis. I do know that the data about that 500,000 tons comes from the greenhouse gas reporting program from EPA. So they're required to report how much they sequester underground, but that doesn't get to the whole life cycle emissions of their process. And I think that the other thing that's important to remember with an early project like this is it's got other value beyond sort of getting to that carbon negative point. First of all, like Dan said, it's decarbonizing their existing process at the ADM plant, reducing their emissions there. The other thing that it's useful for is the innovation value of being a first of a kind project that's really trying to capture biogenic carbon at this scale and sequester it. And there's a lot of value from the learning that can happen from that process. The other thing I'll say on accounting is that as helpful as it is to pursue this project level accounting, the accounting questions also go beyond that. It gets to how do you account this in national level, state level inventories? How do you sort of make these broad level policy decisions about accounting, not just on the level of an individual project?
Myron, anything to add there? All right. I want to move on to a set of questions that's related to a point that both of you brought up, which is about the type of feedstock, the type of biomass that's going into BECCS. And I'll bundle a few questions together here. Um, uh, One I'll just quote because I like the way it's put. Isn't cutting down trees not really good for the environment? Right. So these questions about wood as a feedstock for biomass. There are also questions about ocean biomass. There's some discussion about ocean-based CDR, including a recent report from the National Academies about it. And so what, if anything, is the connection between ocean biomass and BECCS? And finally, a question about municipal waste, right? Organic waste from households, businesses, and so on. So I would invite any or all of you to comment on the significance of different feedstocks, and in particular, wood, ocean biomass, and municipal waste.
So I can jump in to start here. I'm sure Dan will probably make some of the similar points, in part because I've been really dependent on the research that he's done on some of these questions for answering some of this. To answer the trees question first, sometimes it is good for the environment to cut down trees. In particular, in the West, there's a lot of overstocked forests where better management can help reduce wildfire risk. So that presents an opportunity for low value biomass that can be put towards BECCS. In addition, even in other circumstances, these plantations, for example, in the South that are growing biomass for energy do practice, restoring the forest as they are going through. They're managing the forest to promote carbon uptake and to provide other benefits. And they're planting trees as they go along. However, there is this question of temporal scales. This is part of the accounting questions of you have a lot of carbon that you may be releasing or removing from storage, and just planting a tree doesn't necessarily provide a one-to-one substitute. On the oceans question, that's certainly something people are looking into. There's both an opportunity to grow biomass for use in a BECCS process, whether it be algae, macroalgae like kelp or microalgae. This is something in EFI's first BECCS report that we recommended in terms of an R&D need. Actually, both Clearing the Air and our oceans report and our BECCS report, I'll talk about this R&D need. There's also biomass-based carbon removal options that don't have an energy component that you can explore in the ocean context. And then finally on municipal waste. So there's a couple of different things in there. First of all, there's urban wood waste, so opportunities from construction materials or other things to provide wood waste that can go into a wood burning process. That would be another sort of more sustainable source of wood, hopefully, not in all circumstances, but also the opportunities to just sort of have waste to energy incineration with carbon capture. I know that's something that's being talked about. There's a couple of demonstration scale plants, for example, one in Japan and one in the Netherlands, I believe, that are pursuing this. But waste, energy, and incinerators have their own set of community and local air pollution impacts that you have to be really careful of. So it's something that's on the table, but raises its own set of concerns.
Anyone want to add anything to that?
I think that was a great answer, Sam. Encyclopedic, if possible. I think with all of these, there's an ecosystem management context that is tremendously local, and there is an important related question about whether or not this biomass is classified as a waste or not, or a residue, and those really intersect. And I spend most of my time thinking about those contexts, trying to understand when we're dealing with waste biomass or whether there are alternative markets. What are the counterfactual uses here? Is the biomass that is being sourced, truly a waste or a residue, or is it actually a byproduct or even a driver of land management? If that biomass does drive land management, is that something that is ecologically and socially sound? I think it involves talking to locals and talking to experts, people like your local forester. Turns out there are people in cooperative extension whose job it is to really understand these local forest management contexts all across the US. And so the same thing extends to waste management and agriculture. And I wish we knew more about oceans as well.
All right, then let me turn to an issue that Sam had brought up right at the end because it dovetails nicely with some other questions here about local pollution from or related to BECCS. So the more general version is about um, burning biomass. You might also ask about other sources of local pollution, but what other emissions are created and what happens to those other emissions? That you might think of that both as greenhouse gas and other local air pollutants. And then there's also a question about pollution from paper and pulp manufacturing, which Dan had mentioned. And so you might focus on particular industries too. And Marilyn, since I know this is something that you've worked on a lot, I might invite you to go first.
Thanks. Yeah, I think thinking about the local pollution angle of BECCS, especially thinking about uh, uh, local processing of wood waste into wood pellets has been a pretty kind of divisive issue area, also impacting local communities because prior to actually using it in a utility facility or a BECCS facility, wood has to be processed, dried and processed, and during that process, it can release particulate matter, and that particulate matter can really impact local air quality. And then, of course, when using these biomass sources, especially with traditional combustion conversion technologies, you could also have other NOx and SOx emissions that could also impact local communities. And that's partly the reason why the focus does need to be carbon removal, because the traditional ways that we use biomass resources in the past has shown that there's these additional emissions that, if not mitigated, or if practitioners or government regulations don't really control these additional emissions, that they can impact local communities. And so some of that divide really exists when we go from like sort of thinking about ideally what can that technology do, and then once we deploy it, what the sort of challenges could be. So making sure to mitigate those harms will be important. Of course, I should also mention, if biomass is being transported from harvesting and processing locations to conversion facilities, there's also additional emissions that can come from that. And there are ways to mitigate that, whether that is by using cleaner transportation methods or by reducing the amount of distance that can the resource can be transported. There are many ways, but I think the honesty and also really the solution-oriented approach is critical to mitigate local possible harms.
The one thing that I want to add is that, and that's all, it's all consistent with what we've found in our research as well. One thing that people are investigating is whether adding carbon capture can actually help reduce the criteria pollutants, NOx, SOx, PM from combustion facilities, because there's some evidence that it can with natural gas with carbon capture, but there isn't really good evidence yet on BECCS. So people are looking into that question of whether the carbon capture can be part of the solution for these other pollutants.
Yeah, just to underline that really great point, I think carbon capture and storage does have obviously benefits of capturing possible emissions and putting them underground, but these additive local benefits are really like technology dependent. It really depends on what kind of capture and storage that we use, and it also depends on what processes these industries are putting in place to pre-clean the technology. Additionally, of course, different conversion technologies generate different proportion of CO2 or relative purity of CO2 during that conversion process. So all of that detail matters, and it definitely matters for local communities.
Thanks. We only have a few minutes left, but maybe someone can quickly answer the following question about whether BECCS is mainly limited by the availability of suitable biomass or by the available capacity for geological storage. And the point is put this way: if we had unlimited biomass available, could geological storage theoretically absorb 1 trillion tons of CO2?
So I'm not a geologist, but I definitely talk to a lot of them. And they seem, as a community, quite sure that there is adequate storage underground for very, very large volumes of CO2. Just like we have very, very large volumes of fossil fuel reserves that are still, undug and unburned. It seems like there is a lot of space there. I think the amount of, sustainable biomass, and what is sustainable biomass is a fraught question, but is the primary limiting factor of the overall technical potential of this industry. But we can be confident that maybe that gets us to 1 billion tons of year of carbon removal. But it maybe doesn't get us to the 10 billion tons that was in the IPCC reports before, and I think it was 8 that Sam highlighted by 2050. It's small. It's definitely smaller than, and it's definitely smaller than once envisioned, and limited by sustainable biomass, but still hopefully an important part of the climate change mitigation portfolio.
I'd agree with Dan 100%, but and especially on the macro level, but in the near term, there's perhaps a bigger issue with geological storage, which is just the amount of transport, storage, and injection infrastructure can really be an impediment to near-term deployment, even more so than getting the biomass, because we have the biomass supply chain set up already.
Aaron, anything to add? I could give you the last word here.
Oh, thank you. I concur, I guess. But I think for me, it ultimately comes down to regional. We don't want to transport biomass for long distances. We lose a lot of carbon removal as well as energy potential when we do. So it really, instead of globally designing such a system, the regional and specifics and the regional characteristics are going to matter more. I've started to kind of stop thinking globally when it comes to biomass.
All right. Well, that just about brings us to the end of our hour. So I want to thank all 3 of our expert panelists again. Thanks to all of you for attending and for your questions. This webinar has been recorded, so if you've missed some of it or want to go back and review the presentations again, we will post it on our website by usually the end of the week. You can find it at carbonremoval.info. And you can follow us and all of our panelists on Twitter to get more information about BECCS, carbon removal, and related subjects. Have a good afternoon, morning, evening, wherever you are.